Last week, we were discussing about persistent value and persistent value claim. So, persistent value is a piece of storage. It's a piece of storage. Basically, it represents some kind of a storage. So, PVC is nothing but a request to the storage. PVC is nothing but a request to the storage. So, while creating a pod, we will use the claim name, persistent value claim name. So how many types of values are there, persistent values? As we discussed, how many ways we can provision? Static provisioning and dynamic provisioning. Static provisioning and dynamic provisioning. So far, we have created a values as a Kubernetes administrator. We created a persistent values statically, manual. So persistent value access modes. How many modes of values? Persistent value access modes. At high level, we discussed what are the access modes of persistent values. What are those access modes? Read, write, once, read, write, many, read only, many. In AWS short forms, in Kubernetes short forms, RWO, read, write, once, read, write, many, read, write, many, read, write, many, read only, many. These are the access modes. And there are policies, reclaim policies. We call it as a reclaim policies. We have a reclaim policies. As of now, we have this recycle, retain, delete. Guys, these are very important questions in a volume perspective. They will ask what are the access modes, what is reclaim policy, right? So what is reclaim policy? When we are deleting PV, we have a PV and we are creating a claim. When claim is created, it is associated with one PV. So when we delete a PVC, when we delete a PVC, when we delete persistent value claim, based on these reclaim policies, the persistent values will be deleted. Based on these reclaim policies, that persistent value also will be deleted. Claim policies. We call it as a reclaim policies. And persistent value will be associated, can have a several claim policies, right? Retain, recycle, and delete. So when we are defining a PV, when we are defining a persistent value, we are saying reclaim policies. retain, recycle, delete. While creating a persistent value, we are saying what is the reclaim policy. If reclaim policy is a delete, when reclaim policy is delete, it removes both the persistent volume object and also the associated storage. If recycle policy is delete. If reclaim policy is delete. It is something like this. You have your Kubernetes cluster. You have worker, you have master, you have your worker. So when you are creating a PV, persistent value, PV of some type, PV, we have that policy, reclaim policy. We can define a reclaim policy while defining a persistent value. If you see, while creating a persistent value, while creating this PV, we are saying what is the reclaim policy, recycle. And when we are creating a PVC, right, PVC will be associated with this PV. You have a PV, PV has a reclaim policy. So yeah, something like this. Recycle. And when we create a PVC, PVC will be associated with this PV. This is PVC. PVC will be associated with this PV. Again, based on the storage class and based on the request, it will associate. And you have a pod. Pod will get an access to the value via PVC. Now this PVC represents some storage, right? PVC represents some storage. It can be host path. This persistent value can be host path. Or this persistent value can be EBS or NFS, something like this. So based on the reclaim policy, right? When I delete pod, PVC will be still there. PVC will not be deleted. Then if I delete the pod and if I delete PVC also, the associated PV reclaim policy is recycle. What will happen? It will delete everything, whatever it is there in this storage. It will delete the data also. If the reclaim policy is recycle, if I delete PVC, volume will be there, but the data will be deleted. Volume will be there, but the data will be deleted if it is recycle. When the claim is deleted, volume remains there, but it will perform like it will delete, it will scrub the data from the storage. It is like it is going to delete everything inside that storage if it is a recycle. And it is going to make it available for another claim. So when we delete a claim, if recycle policy is, reclaim policy is recycle, when we delete a claim, the volume will be there, but it will delete the data inside that storage and it will make it available for another claim. So PV will be available for another claim. If reclaim policy is delete, when the claim is deleted, both, if this reclaim policy is delete, right? When you delete the PVC, it will delete PV and associated storage, everything. When we delete PVC, it will delete PV and the attached storage, everything, if it is delete. If recycle policy is retain, there are three things. When you delete a PVC, volume will be there, data also will be there, your storage also will be there, but we cannot create a claim for a new PVC. I cannot again claim this value. I cannot claim this value if the recycle policy is retain. When PVC is deleted, the PV will still exist. Volume will be considered as released, but it is not going to available for another claim. So these are the claim policies we have. In the interview, they are asking, guys, what are the access modes? What is reclaim policy? What are the reclaim policies we have? Retain, delete, recycle. When it comes to the values. So here, recycle, delete, or retain. These are the reclaim policies. And when it comes to persistent value, we have a reclaim policy, access mode, and what type of value you are planning to use, and what is the capacity. When we are creating a claim, when we are creating a claim, we are saying how much storage we need and what is the access mode. So based on the access mode, based on the request storage, it will try to associate with PV. When we delete a PVC, based on the reclaim policy, it will recycle or it will delete or it will retain. So these are the reclaim policies. So now, so far what type of volume we are using, I mean to say what type of provisioning we are able to do in this cluster? Static provisioning. Suppose I don't have a PV, I am just creating a PVC. Will it able to create a PV in this cluster as of now? No, right? We need some kind of a provisioner. storage class. We call it as a storage class. Storage class. So what is storage class? Right? Storage class is nothing but some software provisioner. If you see, as of now, we don't have any storage class. We don't have any storage class as of now. Storage class. So storage class is basically provides a way for administrator to describe what type of storage that cluster can offer. Storage class provides a way for Kubernetes administrator to describe what type of storage that cluster can offer. So, like storage class is nothing but some piece of code, guys, provisioner. Each storage class will have a provisioner. So that provisioner is nothing but piece of software. That provisioner is nothing but piece of software. What type of storage you are going to get? Dynamic storage. Like you have a provisioner like AWS EBS provisioner, Azure File, Azure Disk. Like there are these provisioners. So when we have a storage class, you just create a PVC. PV will be automatically created. Now, in this cluster, we don't have any storage class by default. In this cluster, we don't have any storage class by default. If I create a Kubernetes cluster, using EKS or COPS, I will get a EBS provisioner by default. When I create a Kubernetes cluster using EKS, or when I create a Kubernetes cluster using COPS, I will get EBS provisioner, storage class. By default, I will have a EBS provisioner. So in this cluster, if I just create a PVC, what type of volume it will be created? Automatically, it will create a storage in the cloud. So when I create a Kubernetes cluster using COPS or EKS, I just create a claim. I will just create a claim by mentioning storage class as something like this, EBS. I will just create a claim, PVC. I no need to manually create a PV. Automatically, this storage class will create a PV for us. So what type of storage it will create? If I have a storage class with EBS, AWS EBS, dynamic volume, AWS EBS will be created. As of now, in this cluster, we don't have any storage class. If required, I can set up a NFS provisioner. So I can create some kind of a provisioner, so that it will create a volume for us dynamically. If you see now, these PVCs, these PV objects we created manually. Whenever we are trying to create a claim, if volume is there, it is getting associated. So if I have a storage class, volumes also will be created dynamically. Let me show that. Let me delete this, whatever I have created. Let me delete everything. So it is we are deleting deployments service, but PV and PVC will not be deleted when I execute this command. I have to delete manually. If you see, still we have a PVC and PV. So this will not be deleted. I am deleting now manually. I have to delete PVC, then PV. I will delete PVC, then PV. Now if you see, I am trying to create a claim. I am trying to create a claim and I don't have any storage class. That's why I have mentioned manual. If you remove also, that is fine. I don't have any storage class. I have mentioned as manual. And when I create a claim, if there is no PV, it will not create as of now. If you see, if I apply this, we are creating a claim. We are creating a claim PVC. This claim we are using in our pod, as a value. Here, if you see here. Now, when I create this, our pod will not come up. Our pod is in pending state because our pod is using PVC. Our pod is using PVC. We created a PVC, but PVC is in pending state. PVC is in pending state. It is not able to find associate PV. It is not able to find a PV to get associated. And it is not creating also because we don't have a provisioner. We don't have a provisioner. We don't have a provisioner. If you see, let me describe PVC. So there is no storage class. I mean to say the dynamic storage class. Manual, I have given just name as a manual. It is not there. Provisioning is failed. So I have to create a PV manually in this case. Unless until PV is created, your PVC will not able to find PV and your pod will not come into running state. Your pod will be still in pending state because it is waiting for a storage. I can deploy a provisioner, NFS provisioner. In case of these kind of self-managed Kubernetes clusters, I can also deploy some provisioner. Provisioner is nothing but some software. So if I deploy that provisioner, it will be able to create a PV. It will be able to create a PV. So if you see, I have one YML file. I have one YML file to deploy the storage class. Guys, I will come to this. What is service account? Sir, you are creating some service account. You are creating some cluster role. If you see kind service account, kind cluster role binding. I'll come to this. These are like a permissions. What your Kubernetes application which you are deploying, what it can do within the Kubernetes, like what type of permissions that can have, right? So we call it as a RBAC, role-based access control. I'll come to this later. Now, I am creating one deployment using this image, one software. I'm trying to deploy one. I'm trying to create a deployment with one replica using this image. This is one software, NFS provisioner. So here I am giving my NFS server IP address and what is my NFS path for this application, for this software. What is my IP address and what is my path, NFS path. I am creating one deployment. That deployment name here I am giving as a provisioner. So we don't have a storage class. So I am creating a storage class with NFS. If I deploy this YML, I can use this storage class so that it will create a volume object in this NFS. With the help of this NFS server, it will create a PV object. So basically these are the roles, like role, cluster role. So this application, this pod or this software, this container will able to perform these operations within the Kubernetes cluster. It can create a volume, it can create a volume, it can delete a volume, right? So this is one software that I am deploying as a container. I am giving a permissions to this container using service account. Using this service account, whatever service account here we created, this service account is going to have these permissions. It can create a persistent volumes. It can create a claim, it can watch and update the claims. It is like a permissions. I'm giving a permissions to that container with the help of service account and role. We will discuss that RBAC in next classes. Now let me take this YML. I will deploy a provisioner because this is a self-managed Kubernetes cluster. I don't have any provisioner. I don't have any storage class. If you see, we don't have any storage class as of now. So let me take this YML, NFS provisioner. Make sure you update your NFS server IP address and path. There are two places, here and here, the path, your NFS server path, whatever you have given. So let me go and take my NFS server IP address. As a Kubernetes administrator, I am trying to set up, let me take a private IP. I am trying to set up a storage class, dynamic volumes. It will create a NFS volumes. This is my IP address, NFS server IP address. Make sure you update when you are deploying. Path is same. NFS server I have given like a, mnt/share. And let's apply this YML. As a Kubernetes admin, I am trying to set up a provisioner in a self-managed Kubernetes cluster. Now, if you see, I have a storage class. I have a storage class. And while creating the storage class, I mentioned this one as a default. I mentioned this one as a default storage class also. While defining a storage class, I'm saying this is a default storage class. Now, when I create a PVC, let me delete whatever I have. Now, if you see, my pod is not coming because the PVC is waiting for a PV. PVC is waiting for a PV. We created a PV object, persistent value. Persistent value, and it is not able to find a PV, and it is not creating because there is, I have mentioned storage class as manual, so I need to manually create. Now let me do one thing. Let me update my application now. This, I will remove the storage class, or I will mention storage class name as, if I don't mention storage class name also now, if I don't mention storage class name also fine, because this is the default storage class. This is the default storage class, NFS provisioner. I no need to mention something like this. I no need to mention something like this because this is the default one. Now, let me apply, because now I have a storage class. This has to be deleted. You cannot do something like this. First, your volume PVC. We cannot update, guys. PVC is immutable. What is the meaning of immutable? You cannot modify PVC object once it is created. So I am trying to delete that PVC. It is immutable. You cannot modify. Now I am trying to create a PVC. I am trying to create a PVC. If you see, I don't have a PVC, I don't have a PV also. In my manifest file, I am just creating a PVC, persistent volume claim, and I have not mentioned a storage class, so it will use the default storage class. So what is the default storage class in my Kubernetes cluster as of now? This NFS. Now I will just apply this. Now PVC is created. PVC is created. And who created this PV? Did I created a PV? I have not created a PV. We just created a PVC. Who created a PV object now? The storage class, the provisioner, the storage class, this storage class, this storage class. Now if I go and check in my NFS server, if I go and check in my NFS server, if you see, there is one folder got created. Within that folder, this folder is mounted with your pod now. This folder is mounted with your pod now. So this is how Dynamically, it's creating a PV object. I'm using NFS provisioner now. Suppose if I have a Kubernetes cluster with EBS provisioner, whenever I create a PVC, what type of storage it will create in the cloud? If based on the storage class, suppose if I have a EBS provisioner configured in my storage class, whenever I create a PVC, what type of volume it will create? It will create one EBS storage. In a AWS cloud, it will create a EBS volume. It will create a EBS volume here. That volume will be associated with that volume will be mounted with your pod. Dynamic provisioning. When I go for a EKS, I will show you that EBS provisioner. By default, you will have an EBS storage class configured. Now, suppose I want to deploy. Suppose I want to deploy another application. Suppose I want to deploy another application. I can deploy just PVC. So automatically another PV will be created. Suppose if I want to if I create another PVC, automatically PV will be created. Let me show that. Suppose I'm going to create another just PVC. I'm not going to use that PVC anywhere. I'm not going to use that PVC anywhere. I'm just creating just PVC. Just PVC. So this is already there. I will say like PVC1, something like this. Read write once or read only, read write many, something like this. Now, line number 12, we have an issue. Line number 2. There is the indentation is not proper. Now, if you see, we just created a PVC. The PV also got created. The PV also got created. And here, if you see, there is another folder got created. Like this is where it is going to maintain the data whenever I use that PVC in any pod. Whenever I use that PVC with any pod, this PVC, whatever I created, if I use this PVC with any pod, based on the provisioner, the storage, based on the storage class, volume will be created. Now, when we created a PVC, we are mentioning what is, how much storage you need, right? Something like this. Based on the requirement itself, you will create like 1 GB, 2 GB, something like this. While creating PVC itself, you are going to mention based on the requirement how much storage that pod requires. You can create. So if you see, it has to support, the storage class has to support the changes. Now if you see, is it allowing me to resize this provisioner? This provisioner is not allowing me to resize. Suppose when I go for a cloud, like EBS provisioner, it will allow us to resize. It will allow us to resize like EBS, right? If I go for a EBS, the EBS storage class, the EBS provisioner, can we increase EBS volume size? Forget about Kubernetes. Can we increase EBS volume size in AWS? So the storage class, whatever storage class we are going to deploy, the provisioner also, it will allow us to resize. The storage class that provisions must support the resize. This NFS provisioner will not support resize. So this is what we can do with PVC. NFS provisioner. As of now, I am using NFS provisioner. Suppose if you see, there are a lot of storage classes. AWS provisioner. The storage class name is this standard. The provisioner is AWS EBS. Based on the Kubernetes cluster, guys. If I go for Azure cloud, I can use Azure file, Azure disk as a provisioner. If I deploy GKE, Google Kubernetes Engine, what will be the default storage class? This is the provisioner, Google Persistent Disk. So based on the cloud, it will support the respective provisioner. Based on the cloud, it will support the respective provisioner. This is about Kubernetes volumes, persistent volume. Again, there are two types of volumes, static volumes, dynamic volumes, and claim policies, retain, recycle, delete. And again, one question here, guys, does all the volumes support these access modes? I mean to say, like we have a different types of PVCs we can create, right? PV, persistent volumes. We can use host path persistent volume, or we can use NFS persistent volume. We can use EBS, we can use EFS, I mean to say NFS. Does it support these access modes? All the volume supports all these access modes? Again, it is not like that. So EBS, what type of access mode it will support, guys? EBS. So read write once. If you see, Kubernetes persistent volumes, it supports lot of volumes. Like we already discussed, static, dynamic provisioning, all these things. These are the reclaim policies we discussed: retain, delete, recycle. If you see, Kubernetes supports all these persistent volumes like host path, everything, Azure file, Azure disk. If you see this, Azure file, Azure disk, host path, access modes. We have a read write ones, read only many, read write many. These are the access modes. Now, if you see this table, is AWS EBS, is it going to support all access modes? Read write once. What is the meaning of read write once? What is the meaning of read write once? If you see access modes, the volume will be mounted as read write from a single node, only one node, from one node. Read only many, multiple nodes or multiple pods can use same volume. Read write many, the volume can be mounted as read write by many pods, I mean to say many nodes here. So not all the volume supports all type of access modes. If you see NFS supports all the access modes, read write once, read only many, read write many. When it comes to host path, it's supporting only read write once. So these are the access modes in a Kubernetes persistent volumes. So now let's try to understand about stateful set. Now let's try to understand about stateful set. In Kubernetes, we have a one more object called stateful set. There are two types of applications, right? Now, in general, stateless and stateful. Stateless and stateful applications. In Kubernetes, we have a one more controller, one more object called stateful set. One more object called stateful set. If I want to deploy stateful applications like databases, cache containers, right? In Kubernetes, we have a one controller called stateful set. We have a one controller called stateful set. So deployments are used for stateless application. In general, suppose I have some stateless application which I no need to worry about the state, the data. So what object we can use to deploy other applications which are stateless applications? We can go for a deployment replica set, replication controller, something like this. But however, we can use volumes with the deployments replica sets. However, we can use volumes, right? With the replica set, replication controller, deployment, you can use volumes. But what is the problem, right? Suppose I am creating a deployment with two replicas or three replicas. So does each pod will get a different value or same value will be shared? Suppose I am creating a deployment with three replicas and I am using a value in my pod manifest. I am trying to create a three pods. So does each pod will have its own storage? Each pod will have its own storage or same storage, same value for all the replicas? When I use volumes with deployment replica set, same value for all the replicas, guys. When I go for a deployment, when I go for a replica set or replication controller, if I use volume with deployment or replica set or replication controller, it is like same value for all the replicas. Suppose you have a requirement something like this. Each replica should have its own value, its own PVC and its own PV, its own storage. Each pod requires a separate storage, separate value. That is possible only with stateful set. Stateful set. If you see, guys, all the parts of a deployment will be sharing the same value and data, because it is using same value, right? Same value and data. If I use volumes with the deployment, same value and same data across all the replicas. So suppose I have a requirement, each replica should have its own storage, its own value, then stateful set will support that. Stateful set is again a Kubernetes controller. It is used to manage the stateful application. Stateful set is a Kubernetes resource. It is used to manage stateful applications. It will manage the deployment and scaling of the stateful applications. And also what it does, guys, it is not like if you are creating a stateful set with 3 replicas, it is not like all the 3 parts will be created at the same time. It is not going to create all the 3 parts at the same time. If you see the deployment, right, if you create 3 parts, 3 replicas, all the parts will be created at the same time. But when it comes to stateful set, it will guarantee the order. I mean to say, first it will create one pod, then it will go for another pod. First it will create one pod, next it will create another pod, while creating a stateful set with multiple replicas. It provides the guarantee about the ordering. What I mean to say, suppose if I create a stateful set with the name as Mongo, and if it has a 3 replicas, it will start something like this. Pod names will be something like this: Mongo-0, Mongo-1, Mongo-2. So it will follow naming conventions also. Your stateful set name, -0, 1, 2. So every replica of a stateful set will have its own state. I mean to say, every replica in a stateful set will have its own state because it is having its own storage. This part will have a separate storage. This part will have a separate storage. I mean to say PVC. So stateful set is recommended for stateful applications in a Kubernetes because we will always get a stable and persistent storage, stable persistent storage, and stable unique network identifier. Each pod in a stateful set will given a host name as something like this. Each pod will have a, in a stateful set will have a host name that is based on the application name. Increment by something like this: Mongo-0, Mongo-2, Mongo-3. Stable network identifier, I mean to say stable host names, and stable storage. Each and every pod in a cluster is given with its own persistent value. Deleting or scaling down the pods will not automatically delete volumes, guys, if I use stateful set. So stateful set is recommended for stateful applications in a Kubernetes cluster. In real time, if you are trying to deploy databases also as a Kubernetes pods, or some cache softwares like Redis cache, Memcache, these kind of softwares, if you are trying to deploy in a Kubernetes as a pods, which is recommended and what will be used, what controller we will use is stateful set. And if I want to use stateful set and if I want to access stateful set, what type of service I have to create? We have to create for a stateful set. Because I want to treat each pod as a separate. I don't want to have load balancing between my stateful set pods because I want to connect as a separate. Stateful set can have a multiple replicas, but how can I connect without load balancing? What type of service we have to create for a stateful set? Headless service. Guys, what are the service types we discussed so far? What are the service types we discussed so far? We created a services, Kubernetes services. What are the services we created so far? What type of services we created so far? Like cluster IP, node port. We have a one more service called load balancer. I'll come to that later. Now we have a one more service called headless service. So when I create a service of type cluster IP, if that service has 3 replicas, will it act as a load balance? Will it act as a load balancer or not? Whenever we are accessing using that service name, if service of type cluster IP internally, when I am accessing that service, cluster IP service, it will act as a load balancer. Now, there is a one more service type called headless service. I will get a DNS. Without load balancer. So when we create a stateful set, we have to create a headless service. So let me demonstrate stateful set. Let me delete everything, whatever I have created. Whatever I have created, let me delete everything. I will delete PV and PVC also. Now, I am going to create stateful set instead of using a replica set or deployment for deploying application. Instead of creating a replica set or deployment for an application, for database, I am going to use stateful set. So let me show that how to create a stateful set. So database, this is front-end application. Let me take everything into one YML, then one text pad, then I will modify. So now, here, when I am creating this application, right? For front end, I am using deployment. So there is no change here. For backend, I am going to use stateful set. I am going to use stateful set instead of using this replica set. I am going to use stateful set. If you see the stateful set YML, something like this, it is there in our GitHub. I will show that. If you see the stateful set, it is something like this. It is something like this. Not this one second. MongoDB stateful set. Something like this, stateful set. This one. And you no need to define a persistent volume also. Now, API version app/v1 kind stateful set. This is my stateful set name. And here we need to define a service name. If I don't give this service name, it will not work. While creating a stateful set itself, you have to mention what is the service name. When we are creating a deployment or replica set, did we mention the service name while in the deployment manifest or replica set manifest or replication controller manifest? We have not mentioned the service name. What is the service for that deployment? But when it comes to stateful set, we have to mention the service name. Service name, how many replicas you need, right? Again, template, same thing. Labels, you can give label as app/mang, this Mongo. Everything same. Selector also. But when it comes to here, volume mounts is same. But here, what we are defining, there is a claim templates. What is your volume claim template? So each and every replica will get a claim. Since I have a storage class, so do I need to create a claim? This is claim template, guys. This is claim template. So it is not a claim name. So you are defining a volume claim template. When it comes to stateful set, you are defining a volume claim template. This is like a template for your PVC. So I no need to create a PVC. And also I no need to create a PV also manually because I have a storage class configured, dynamic storage. So here we are defining a claim template. This is my claim template name. What is the access mode? How much storage I need? Now, if I have a 3 replicas, how many PVCs will be created and how many PVs will be created for this stateful set now? Suppose if I have a 3 replicas, if I mention replicas as 3, how many persistent volumes and volume claims will be created? As I discussed, stateful set, each pod will get its own PV, its own PVC. So how many PVCs will be created if I have a stateful set with 3 replicas? 3. And again, I no need to manually create a PV, PVC also because I have a storage class. So stateful set, I am defining a claim template name. So it will create a PVC and also it will create a PV because I have a storage class configured. So here I can mention the storage class name also, what storage class it has to use. But if I don't mention, it will use the default storage class, whatever has been configured in your cluster. Now I need to create a service. I need to create a service. But what type of service I can create for a stateful set? We can create a service of type headless service. How to create a headless service? Something like this. Cluster IP none. Cluster IP none. We will get a DNS name. We will get a DNS. It will create a DNS record, but it will not have a load balance. It will directly reach the pod. So now let me take this YML and deploy the application. Front end I am using deployment. Back end I am using stateful set, right? 3 replicas. If you want to create only one replica, you can create one replica. Now, it will work something like this, service name. I can pass as a Mongo also. Suppose if I have a 3 replicas, when I use service name as Mongo and it is headless service, always it will reach only first pod. Always it will reach only first pod. Because there is no load balancing. There is no load balancing, right? If I want to reach individual pods, I can use something like this. Mongo -0.mongo. Something like this. First pod, it will reach first pod. If I have something like this, second, something like this. So individually also I can connect. If I just mention Mongo, even though the service has 3 endpoints, it will not do the load balancing. It will always contact the first one if I pass something like this, if I use something like this. In the front end application, if I use something like this, it will always reach first one. If you want to connect to these replicas individually, you can use something like this. What is this? And what is this? What is this one? This is your pod name in a stateful set. That is nothing but your host name. And what is the second one? What is the second one? This is your service name. The second one is service name. So the first one is, if you want to reach individually, you can use something like this. Something like this. Or you can use something like this. It will always reach the first one. Now let me create an application with stateful set, backend as a stateful set, app Mongo. While creating a service, cluster IP is none, which means it is a headless service. And my pod labels are app Mongo. Selector is also app Mongo. So let me deploy this application. So now the backend, the database, I am trying to use stateful set. Instead of replica set, I am using a stateful set. I mentioned as a 3 replicas. If required, you can mention only 1 replica. Now each pod will get its own value. And since I have a storage class configured, I no need to manually create a PVC, PV, and this template will create a PV. This template will create a PVC. This template will create a PVC, and PVC will create a PV because we have a storage class configured. Now something like this. Let me apply. If you see, as of now, I don't have any stateful set. I don't have any stateful set as of now. Nothing is there. I don't have PV, PVC. Now I am creating a database pods with stateful set. Now if you see, the pod name, you will get a unique network identifiers. So this is your pod name, that is your host name, that pod host name. Is it creating all the 3 replicas at once, guys? Or it is doing one by one? First it is creating the first replica, then it is creating the second replica, then it is creating the third replica. In a stateful set, it will maintain the ordering. Now if you see, I have a 3 PVCs, I have 3 PVs. So each pod will have its own storage. Each pod will have its own storage. Right? So we can use stateful set for a stateful applications in a Kubernetes cluster. What is the advantage? How different is from deployment? This is very important, guys. In some interviews, they can ask this question. What is the difference between deployment or replica set with stateful set? What is the difference? Stateful set are for a stateful applications. We will get a stable network identifier. We will get a stable storage, which means each pod will have its own storage, and also each pod will be having its stable network, stable host name, something like this, always something like this. Now, I can use this to directly connect to this one. Suppose some front-end pod has to connect to this one. We can use something like this. If I want to reach this guy, I can use something like this. If I want to reach this guy directly, the pod, I can use something like this. And if you use service name, only service name, even though it has a multiple replicas, always it will contact the first available pod. If you use something like this, your service name, always it will reach first available pod. So this is how you can use stateful set. Stateful set is for a stateful applications in a Kubernetes cluster. The difference you see here, guys. In a stateful set, you will see volume claim templates. You are going to define a template for your volume claim. And if you see how it has created, I defined a volume claim template. If you see what is the volume names, PVC names it is using. how the PVCs got created using the template. This is my volume claim template name. And if you see, your volume claim template name, Mongo-0, Mongo-1, Mongo-2. This is the PVC. So this PVC is used by the first replica. Second PVC is used by second replica. This PVC used by third replica. And it is associated with this PV object. Since there is a storage class configured, I have not created the volumes also manually. It is created by the storage class. These volumes are created by storage class. So these are the objects which we can use to deploy our applications. What are the objects we can use to deploy our applications? We have a pods. Can I directly create a pod? Again, let's revise. Can I directly create a pod? If I directly create a pod, what is the disadvantage? If pod is deleted, will it come up automatically? Can we scale up, scale down? We can't scale up, scale down. And if pod is deleted, it will not be recreated. So for that reason, we have a replication controller, replica set, deployment. We have a daemon set. And now we discussed about stateful set. Service is different. Service concept is different. We have a headless service. We have a cluster IP service. We have a node port service. We have a load balancer. We will come to this later. And we have a PV-PVC. This is for what? This is a storage for your pod. Storage for your pod. PV-PVC concept. Service is for what? Service is for basically network communication. Suppose you want to connect your pods without load balancing. Suppose you want to connect your pod without load balancing. You want to directly reach the pod. So you have to create a headless service. Suppose I have a 3 database pods. I don't want to use load balancing. I have to directly reach all the 3 database replicas. Then go for a headless service. Service for, there is another service called external. Service of type external. That is, you are trying to connect to some external source and you don't want to hard code IP address of your external server. You want to connect some external server or application. You don't want to hard code that one in your each and every pod. Suppose in future that external server or external service IP is changed, you no need to update each and every time. What you can do, you can create a service of type external. There you can mention the destination. You just update your external service so that it can, it will try to connect to that, external service using that name. So this we will not use most of the cases for external service of type external. Now this is network and communication. This is for a storage. These are your process. Now deployment for a stateless application. For a stateful application, stateful set. Then what is daemon set? What kind of applications we can deploy in a daemon set? What kind of applications we can deploy in a daemon set? Suppose each and every node should have a pod. Then you can go for a daemon set. Some software which is required in each and every node, you can go for a daemon set. These are the objects we discussed as of now. For deploying our containers, we can use this. This is for a communication. This is for a storage. Your data, if you want to maintain the state of your Kubernetes pod, you can go for a persistent volume claims for your pods. Now let's try to understand this YML. And do you see any problem with this YML, whatever we use so far? Like whether you are using a stateful set or whether you are using a deployment or replica set, that is fine. Do you see any problem? Are we following a best practices here and here? So what is the problem here? Here, especially here, right? Here as well as here. Your front-end application, you are passing something as an environment variable. Your backend also you are creating with some password. So here, what is the problem here? Environment variables. We are passing as an environment variable. And also the password. Password is open. Can I use same YML for multiple environments, guys? Can I use same YML for multiple environments? Suppose what if for another environment, my database password is different. My database username is different. Can I use same YML without modifying this YML? Can I deploy the same manifest for another environment? We cannot do that. And also passwords are in human readable format. This is also one source code. This is also one source code. I will maintain this YMLs Spring manifest in a GitHub. So this is also source code. Is it recommended to have confidential information in a version control systems in a human readable format? Are we going to maintain something like this as is? We should not. So how to handle these? In Docker, how we how we hide confidential information in Docker Swarm? What concept we used to hide confidential information? Secrets. Similarly here in Kubernetes, we have a concept of config maps and secrets. Similarly, here we have a concept of config map and secret. So Kubernetes allows you to provide a configuration information to your applications using config maps and secrets. We can use config map and secrets to pass configuration information like environment variables. Configuration, which it is going to vary for every environment. Like application configuration will vary between multiple environments like staging, production, development environments. Like it includes like database details, database connection details or credentials, right? Which may change for each and every environment. So in Kubernetes, we can use config maps and secrets to pass that information to our applications in a Kubernetes. So we can define a config map or we can define a secret. That is also one kind of object, guys, Kubernetes object. We can define a config map, we can define a secret. That secret we can refer in our manifest files. Instead of passing something like this, instead of passing something like this, here, instead of passing the value, I can say value from config map or value from secret. I need to create that config map and secret in a Kubernetes cluster so that values we can refer from a config map and secret. So tomorrow we'll try to continue with config maps and secrets. Tomorrow we'll try to discuss about config map and secret. And also there is a concept called liveness probe and readiness probe. There is a concept called liveness probe and readiness probe. So tomorrow we'll continue with this. After this, if time permits, we'll try to discuss about advanced scheduling options. Advanced scheduling options. In Docker, how I am controlling, suppose I have a requirement, this pod has to be created in so and so node. Sorry, in Docker, we created a service. When we are creating a service, when we are creating a containers, suppose you have a requirement, this container has to be created in so and so node. What concept we used in Docker, guys? Docker Swarm. What concept we use to control the placement of your containers? Suppose you have a requirement, this container has to be created in exactly that node or group of nodes. What concept we used in Docker Swarm? We used labels and constraints, right? Similarly, here we have some scheduling options, advanced scheduling options. We have something like this. We have a basic scheduling option, node selector, basically labels and selector, node selector. We have some advanced scheduling options like node affinity. We have a concept called taints and tolerations, right? Scheduling, pod scheduling. Suppose you have a requirement that pod has to be created in so and so node only. So what concept we can use in a Kubernetes? So we have a concept of node selector, labels and selector, node labels and selectors. It is like a constraints only. We have some advanced scheduling options like node affinity, taints, and tolerations, right? So we'll discuss this tomorrow. We will try to cover these topics tomorrow. Later, we will go for how to set up EKS cluster. Then we will discuss what is load balancing service, what is ingress. We'll discuss these topics later, guys. Okay. We'll continue tomorrow, guys. Try to set up NFS provisioner. All the YMLs are there as part of this. I will give the running notes also. Try to deploy NFS provisioner. You just create a PVC, it will create a PV object for you. We'll continue tomorrow, guys. If you have any questions, let me know. I have 2-3 minutes. I can explain if you have any questions, queries. Else we'll continue tomorrow.